picking up where we left off in lesson 1-4. Yesterday, if you recall, we talked about functions, right? We talked about composition of functions. That's where we spent most of our time. So we talked about Fogg and Goff. And towards the end, we talked about those compositions, Fogg and Goff, and we looked at finding domains. Excuse me. Remembering domains, things like radicals and denominators affect our domains. So when we did, just real quick, so like when we did Fogg up here, remember Fogg was f of g of x, right? And that's where we were taking g of x and putting it into f of x. So as we look down at, we're going to do the opposite here. That was composing functions. Now we're going to decompose functions, that is. So to decompose a function into two composed functions, we want to think about finding like what's the inside. So that inside that we can then plug into an outside. So we're trying to take Fogg here basically and undo it. Okay. So you'll notice right here it says that h of x is f of g of x. So we're trying to break this down into Fogg. Keep in mind the inside then is g of x. F of x is going to be the outside. So as we go through and do this, I want to come up with something that could be an inside function and something that can be an outside function. I will tell you, not every problem has necessarily one right answer. There are some of these that you can come up with something else that works. Now, there is more often than not one more obvious answer. Okay? But again, not something that, not always one definite. So as we look at this, we're trying to pick what's the inside that we're plugging into some outside. And remember the inside I'm going to call g of x. The outside is going to be called f of x. So is there some inside that you see that can plug into something else? And I would say try and pick out the inside first. Any thoughts on what you guys want to use as the inside? X plus 1? Do you guys see that? And in this particular case, you see multiple x plus 1s, right? So multiple x plus 1s make me think that I want to use x plus 1 as the inside. So now, as you think about that, it's x plus 1 squared minus 3 times x plus 1 plus 4. Those insides replace what? Those insides replace x. So every place there's an x plus 1, what is that going to be now? An x. So that's going to be an x, and that's going to be an x. What's my outside equation then? You guys see that? X squared minus 3 times x plus 4. I don't know if that helps or not. I'm just trying to look for different ways to make this work. So x squared minus 3x plus 4. If you're a little hesitant on what you're doing on some of these, and this is what I have to do when I will grade your quiz next week, is because I'll have something like this on here, and I'll have to grade it with the idea that, okay, this is what I think, like the obvious answer is, but if you give me something different, I'm going to check and see if it will possibly work. And so check this and see, okay, if I'm trying to find Fogg, f of g of x, x plus 1 has to go in right there, and it has to go in right there. Are we okay with that? Did you see any others for this one? To me, this one is more obvious. This is about the obvious one. I'm not saying you couldn't come up with something else that works, but... Okay, let's try B then. B, they give me an h of x again. Square root of x cubed plus 1. I want an inside and an outside. Or in other words, I want a g of x and an f of x. So my suggestion is always look for the inside. What can I pull out as an inside? And then we'll go from there. Okay. I heard x cubed plus 1 from a couple of people. Okay, I like that one. And that is my inside, right? So think about it. If we have x cubed plus 1, and that's my inside, what did that replace? That replaced x. So what's that make my outside? Square root of x. You guys okay with that one? Now, on this particular problem, did you guys have another thought? What did you say? Okay. What if instead, okay, this is my original, yes? What if instead you made your insides x cubed? So if my insides are x cubed, what would that x cubed replace? X. Could we do that? Yeah. I'll be honest, this is my less preferred one. I mean, I'm not crazy about this one, but does it work? It works. I prefer the other one. To me, I like it better. So I'm going to say or. We could have used g of x, the inside, to be x cubed. And if we do that, the outside f of x is the square root of x plus 1. And again, try and put them back together to test them. Because that's what you'll always see me do. If you bring an answer to me and I'm not sure, or if it doesn't agree with mine, I'm going to test it before I say, no, it isn't right. Questions on that one? Okay, let's flip to the back then. In the medical procedure angioplasty, a catheter is inserted into a heart vein in order to inflate a small spherical balloon. Suppose the balloon inflated at a constant rate of 44 cubic millimeters per second. Important minor detail there. Okay, so we have a parts A, B, C here. I will tell you that A, B, C kind of go together, they build. So A. Find the volume after t seconds. Find the volume after t seconds. Do we know the volume after 1 second? Are we saying yes here? I see some heads nodding at me. What's the volume after 1 second? 44? Because the rate they give me right here is 44 cubic millimeters per second. And what's cubic mean? Cubic is volume, right? So after 1 second, it's 44 cubic millimeters. So what do you know is happening after 2 seconds? Basic math tells me after 2 seconds, it's 88 millimeters per second, yes? Well, they want volume after t seconds. What formula can I write for volume after t seconds? 44t, because it's the volume for 1 second times how many seconds are we talking? 5, 10, 20, 60. And so V equals 44t. Are we okay there? Okay. When the volume is V, what is the radius R? When the volume is V, what is the radius R? So we need a connection between V and R. Specifically, I want an equation that connects V and R. So what do we know about volume and radius? Okay, so volume and radius of what? Does it give me a what in the problem? We're trying to inflate a small spherical balloon. So volume and radius of a sphere. I don't know, does anyone know that formula?
It's like
4/3 pi r, nope, it's volume, cubed. Okay, so the formula that connects this is V equals 4/3 pi r cubed. And that's just volume of a sphere. You've seen that volume before. It's a good one to start to know. It is. I'm not saying I expected you guys to know it because I knew that, it wouldn't be the popular answer there, but they're asking when the volume is V, what is the radius? So what do I need to do with this question? If they're asking what is the radius, okay, we need to solve for R. Okay, so how do you want to solve for R? Okay, so I want to get R by itself. I'm going to disagree with subtracting just because I don't see any addition. I'm not going to subtract if I don't see addition to undo. I would start with that fraction. How can I move that fraction? Multiply by the reciprocal. So to move the 4/3 that's being multiplied over to the other side. I mean, yeah, technically you guys could tell me to divide by 4/3, but yuck. Let's multiply by 3/4. If I multiply the left by 3/4, multiply the right by 3/4. What is 3/4 times V? 3/4 V. Or where would the V go in that fraction if I want to put it in the fraction? The top, yes? And because of what I'm doing next, that's why I'm writing it this way. So I'm going to write this as 3V over 4 equals pi r cubed. And maybe I should have done this in the previous step, but I didn't. I'm breaking it down. Now, how do I get R by itself? Okay, so we say divide by pi. I agree. However, that means over here I'm going to be doing a fraction divided by pi. Dividing by pi is going to be multiplying by what? No. 1 over pi, right? Dividing by something is multiplying by its reciprocal. What's the reciprocal of pi? 1 over pi. So I'm going to take the route of let's multiply by 1 over pi. And again, I'm doing this because I already have a fraction over there. So if I multiply by 1 over pi, what do we have? 3v over 4 pi, and that is equal to r cubed. So I'm going to write r cubed equals 3v over 4 pi. Okay, final step in solving for r. Cube root. So r is equal to the cube root of 3v over 4 pi. And I am leaving that as is. Yeah. I'm not sure what you're doing in your head there that you're going to clean up, but are you rationalizing it for me? You get that rationalized. Let me know when you get there, okay? Personally, I'm going to leave this one like this. Questions on part B? Okay, let's try part C. Because part C uses part A and B. Write an equation that gives R as a function of time t. And then, what is the radius after 5 seconds? So hold that thought of what is the radius after 5 seconds. That is for a later point in time. I want to write this equation that gives R as a function of t. When we say something gives R as a function of t, that means it's R equals, and the variable in the equation is t. So R as a function of t. Meaning an R equals equation with t as the variable. Yeah, I already kind of hinted that we're going to use A and B, didn't I? If if B, let's go that way, is R equals the cube root of 3V over 4 pi. Okay, that's what we had part B was. So right there, that is R as a function of V, because V is the variable in the equation. Since we want it to be R as a function of T, we're going to substitute for V and put it right in there. So R is the cube root of 3 times, what was V? 44t over 4 pi. Clean up. It is. But I'm not going to leave it like this. I'm going to clean it up. How can I clean that fraction up? What'd you say? Maybe. I'll be honest, I don't know what it multiplies to be. Okay. He's thinking it's something like 132t. I don't exactly have it in my head because I'm going to do it I had a different way in mind. Okay, but, so what's he doing? He's multiplying this. And then the key is, if it's 132t, can that simplify? And here's the deal. I know it can because, what do you notice about 4 and 44? Don't 4 and 44 divide by a common factor? So I was going to cross cancel before I multiplied, or simplify before I cancel. So 4 divided by 4 is 1. What's 44 divided by 4? 11. So now if I clean that up, 3 times 11t, this is going to be the cube root of 33t over pi. So that is the equation they asked for the first question. What's the second part of the question ask? What is the radius after 5 seconds? What do you think we do? Yeah, plug 5 in for t in the equation we just found. R is the cube root of 33 times 5 divided by pi. Obviously, that is a calculator problem at that point. I don't know how comfortable you guys are on your calculators, but I would just plug that all in at once. Do you guys know where cube roots are? Cube roots, I believe the best, unless are they up here? Okay, there is a spot there. So cube roots, the best place to find them is the math menu. Number 4 is a cube root. Number 5, what's that mean? I can make any roots I want. 4th root, 5th root, 6th root. So number 4 is my cube root. You can do a fraction under your cube root. 33 times 5 And I'm going to be precise and use my pi symbol. And so I've got plugged in exactly. I don't have to do any work then past that. Did you guys get the same answer I did? So this is the radius. What is the radius approximately? .74. 3.74 what? Millimeters? Millimeters, yeah. So the whole decimal, if you had it, was 3.744938504. Rounds to be approximately 3.74 millimeters. Okay. Your homework, if you haven't already gotten started on it. Page 116. 2 through 8 evens. 12 through 30 even. And don't forget 31. If I had my guess without looking at it, 31 is what we just did. It's the type of problem we just did. You have work time. Use it, please.